Express in polar form, give answers to two decimal places where appropriate. Note that we're going from Cartesian to polar. In this case, it's a good idea to do a sketch. So let's start with part A, where we're given 2, 2. So if we sketch where 2, 2 is, 2, 2 is here. So it's at the point 2, 2, which means this distance is 2, this distance is 2. This will be a right-angled triangle. We're interested in r and theta. Using Pythagoras, r would be the square root of 2 squared plus 2 squared, which is the square root of 8, which you can write as 2 root 2. That would be the exact answer, but we're asked for 2 decimal places. So if we do the square root of 8, that's 2.83. Since this triangle is right-angled and isosceles, it follows that this angle must be 45 degrees. Therefore, the polar coordinates would be 2.83, 45 degrees if we're working in degrees, and 2.83 pi by 4 if we're working in radians. Now in part B we have -1 root 3. So once again let's do a sketch. -1 root 3 would be about here. So that would be 1, that would be root 3. Now if we work out this angle, we can then work out the angle that we want. So r squared is going to be the square root of root 3 squared plus 1 squared. So that's the square root of 3 plus 1, which is 4, giving us 2. Sorry, that's r, not r squared. Now, tan phi is equal to root 3 on 1. Now, you can use a calculator for that, but we should know that phi is therefore 60 degrees, and that means the angle that we want, theta, is going to be 120 degrees. So the polar coordinates for this are 2 and 120 degrees, or in radians, 2 and 2 pi by 3. Now let's look at part C. Again, let's produce a sketch. -3, -4 will be here. And we form this right angled triangle. This distance is 3, this distance is 4. Now, for r, we can use Pythagoras, or we may spot the 3, 4, 5 triangle. So r is equal to 5. Let's call this angle phi. And remember, the angle we want is going to be the whole angle around there. So phi is going to be the inverse tangent of the opposite over the adjacent, which is 4/3. So we're going to do the inverse tangent of 4/3. And that gives us 53.13 degrees. And that means that theta is going to be 180 plus that. So that's going to be 233.13 degrees. So we have 5 and 233.13 degrees. If we want that in radians, then let's add the 180 and then we can multiply that by pi and divide by 180, and that gives us 4.07. So it'll be 4.07 if we work in radians. Finally, for part D, we have 5, -1. So 5, -1 would be, say, here. And this would be R, right angle triangle, 5 and 1. And so R would be equal to the square root of 5 squared plus 1 squared, which is the square root of 26. Working to 2 decimal places, we want the square root of 26. That's 5.10. We also want this angle here, phi, but remember the angle we want to give is right the way around from the initial line to here. So phi is going to be the inverse tangent of the opposite divided by the adjacent. And so we can work that out. So it is going to be the inverse tan of 0.2, which is 11.31 degrees. Then the angle we want is going to be 360, take away that angle. So 348.69. So we would give 5.10, 348.69 if we're working in degrees. If we're working in radians, we want to take that answer and multiply by pi, divide by 180, and that gives us 6.09 radians. So it'll be 5.10, and let's just check that answer, 6.09.